Okay, we're going to do the test revision. We need to work out the slope of this line. They've given us several points here. We take these two here. To get the slope, we can just use rise on run. Now the rise is this y step, and that's a drop of 2. So we do rise divided by run. The run is the x step, and that's 3. So the slope is minus 2/3. This one here, they've given us 2 points, so we could actually use the triangle between those 2 points because those points lie exactly on the grid line. You could choose another triangle, like it looks like this one here. You could use that, but we're not really sure that's hitting, this one here is hitting exactly on the grid, so we'll use those their given points. And looking at the rise, you can see there's 3 up to here and then another 5 up to there, so total we've got 8 for the rise, and the run, which is this one, is 5, so it's 8/5 is the slope. This one here, we could do rise and run, but they've given us the coordinates, so it's 6 across and 862 up, 11 across and 1080 up. So because they give us the coordinates, instead of using rise on run, we could use this method, y2 take y1 on x2 take x1, where this is x1 y1 and this is x2 y2. So doing the difference between the y's, we do 1080 minus 862, all divided by the difference between the x's, 11 minus 6. Now if you do that on the calculator, you get 218 on the top and get 5 on the bottom, and so when you divide that, you'll get, you could go to a decimal, 43.6 on the calculator, or just leave as a fraction. So that's using the formula way. This is the formula way, y2 take y1 and x2 take x1. The top two is using the graphical way, which is rise on run, rise divided by run. So 2 methods for getting the slope. Question 2, draw a line through 1, 3 having a slope of minus 4. We'll set up our axes first. So we're going to plot 1, 3, so you go across 1 and you go up 3, 1, 2, 3, so it's there. Now we have to have a slope of minus 4, and a slope of minus 4, that's the same as minus 4 on 1, and that means the rise is this one, that's the rise, and this one here is the run. So if we run across 1 from that point, that'll go to there, and then we rise, which a negative 4, which means drop 4. So you go across 1, and then you go down 4. 1, 2, 3, 4. So that's our second point. And if we join them up, that'll give us a slope of minus 4 through that point. This is x, and that is y. Question 3, find the slope of the line joining these 2 points. I did one like that up here on the graph. You don't need to graph it, you can just use y2 take y1 on x2 take x1. Now that's x1, that's y1, this is x2, that's y2. So the y2 take y1 is going to be 3 take 5, x2 take x1 is going to be 2 take 1. 3 take 5 is minus 2, 2 take 1 is 1, so the slope is negative 2. So we're doing y2 take y1 divided by x2 take x1. Find 2 points whose slope of the line joining them is minus 3. We need to get 2 points so that the slope is minus 3. Actually, it's more likely to be something like that because it's a negative slope, it's got to go down. and we have to think of the 2 points that would have that slope. Now slope is rise on run minus 3 on 1. So we could consider that this y step has to be a value of 3, and the run, this one, has to be a value of 1. So if we made a point up here, if we just made a random point like 1, 2, then if we're one value across on the x coordinate, then this goes up to 2. That 1 there has gone up to 2 because we increase it by 1. And the y coordinate has to go down by 3. So 2, when you go down by 3, you'll end up at minus 1. So there's an example of 2 points, 1, 2, 2, minus 1, which would have a slope of minus 3. And there's many other examples that you could do. What is the slope of a line perpendicular to the line in question 4? If perpendicular slopes, you've got to flip them upside down and put a negative, do the inverse sign. So we flip 3 on 1 and it becomes 1 on 3, and do the opposite of minus, which is plus. So that's the slope of the perpendicular line. So if we continue that line like that, it's this line here. This slope here has is 1 on 3. Okay, fill in the blanks. This is based on the concept y equals mx plus c. The slope is in front of the x and the y-intercept sitting off by itself. So the slope here is 3 and the y-intercept is 5. The slope here is minus 2 sitting in front of the x and the y-intercept is 7. Here the slope is 6. There's no y-intercept because you can imagine that's 6x plus 0, so there's no y-intercept. Y equals 5 is a horizontal line, so it'll have 0 slope and it cuts the y-axis at 5. The x equals 5 is undefined and it doesn't cut the y-axis too, so you can't do that. So just explaining y equals 5 and x equals 5 in detail. You've got a set of axes like this. Y equals 5 is this line going like that, cutting through at 5 and staying horizontal, whereas the x equals 5 is the vertical line cutting the x-axis at 5. This is x equals 5, this is y equals 5, this is the y coordinate, this is the x coordinate. And the last one, 9x plus 3y equals 6, that's not in the form y equals mx plus c, so we need to rearrange it first of all. I'll just give a bit of room. So what we need to do is take the 9x over the other side. At the moment we're plus 9x, on the opposite side we're going to be minus 9x. Now we've got to get the 3 over the other side. At the moment we're times 3, so the opposite of times 3 is divide 3. Now we'll just divide those two separately by the 3. So that's 6 divided by 3, which is 2, and 9 divided by 3, which is 3. So y equals mx plus c, we can see the slope is the number in front of the x, so that's minus 3, and the y-intercept is the 2. So these are the two answers for this line. Now an application question. We've got Bill and John, and you have to explain in your own words what you think is happening over the 50 seconds. This is 50 seconds here. So clearly you've got to say that John leaves at the starting line at time 0, and he heads off at a fast speed because he's steeper than Bill, the red line. So John's going faster than Bill, and John overtakes him at around about this point, and then John continues on and Bill keeps going along at his slow pace. But Bill's had a head start. He started at the 40 metre mark in front of the starting line, whereas John started at the start. And you can easily see the point here where they actually pass, so it looks like it's about 110 metres, 10 metres from the start line, and the time at which it occurred It's a little bit difficult because it's in between two grid lines, but it looks roughly about 35 seconds. You could work out the slopes of those two lines, and that's what we have to do question 8, because I need to work out the equations. So we need to know the slopes and the y-intercept. So we'll work out the slopes of John and Bill separately. If we look at John, we could get a triangle like, we could get one about there. It's intersecting probably about that line there. So there's our triangle all the way down and across. Now the run is 20, because you look at that scale, each square is 10, so that's 20 across, 2 squares. And going up, that's 60. So 60, rise on run, 60 on 20 is 3, so that's John's slope. If you look at Bill, we'll get a triangle for Bill, and we can see that we could do, let's see, we could start there, we could go across, and the next time it hits a grid line would be possibly that one there. So using that triangle, you can see the run along here is 10, 20, and it's probably at 20, and then up this, sorry, that's 30, we'll go 10, 20, 30, and then we go up vertically up to this point, and we can see that the rise is 10, 20, 30, 40, 50, 60. So that's 60 up there. So 60 divided by 30 is 2. So we can say Bill's slope is 2. Now we can write the equations for Bill and John. So Bill is y equals 2x plus c, and John is y equals 3x plus c. We just need to get the c's, that's the y-intercept, and for Bill, he cuts at 40, so instead of c we have 40. Whereas John, he cuts at 0, so instead of c you've got 0. So they are the two equations for the two lads. So that's what this question in here is asking for. 9, use your equations to work out how far the two people are after 100 seconds. So we'll do, first of all, we'll do Bill. So Bill is y equals, and he is 2x plus 40, but we want it for 100 seconds. Now 100 is an x value, so we substitute it into the x. So it's 2 times 100 plus 40, which is 200 plus 40, which is 240 meters. So after 100 seconds, Bill's 240 meters from the start line, whereas John, he is y equals 3x. We actually put the 100 seconds into the x here, 3 times 100, and so he's equal to 300 meters. So John's 300 meters and Bill's 240 meters after 100 seconds. Use your equations to find out what time the two people will be 200 meters from the starting line. Okay, this time we have y equals 2x plus 40 for Bill. But this time, instead of putting this 200 is a y value. That's a distance on the y, so we put 200 where y is in there, and we want to solve this equation. So to solve that, that's plus 40, take it over the other side, it'll be minus 40, and so we're down to 160. And now we've got to, that's times 2, to get on the other side we've got to divide by 2. So the answer is 80. 80 seconds. So after 80 seconds, Bill will be at the 200 metre mark. Whereas John, he is y equals 3x, and we want him to be 200 metres. We put 200 metres where y is, and we solve for x. Now that's times 3. To get 3 on the other side, we divide by 3. And so we'll get, that will be 266.7 rounded off meters. Okay, so, oh sorry, seconds. So after 66 seconds, John is 200 meters, and after 80 seconds, Bill is 200 meters from the start. Okay, and the last question, use simultaneous equations to find out when the two people pass each other. So this is a bit more advanced question. We need to write the two equations down again. Y equals 2x plus 40 and y equals 3x. And we want to know when these two are the same. Now all we need to do is use elimination. We're going to subtract. We call this equation 1 and that equation 2. We're going to subtract the two. 1 take 2. And actually I'll do, just to make it a little bit easier with the numbers, I'm actually going to do equation 2 take equation 1, because then we'll get a positive x. So y take y is 0, 3x take 2x is 1x. We could put a 1, but 1x is the same as x. And 0 take 40 is equal to minus 40. So we've got 0 equals x take 40. Now get 40 over the other side, plus 40 to the other side, and so x equals 40. And so they pass each other at 40 seconds. After 40 seconds. You could easily work out the distance by substituting that 40 into any one of those two equations. So if you sub it into 2, then you have y equals 3 times 40, which equals 120 meters. So that's when they pass each other. Okay.